Of all my differing combat robots, Subdivide A is definitely one of the most fun to drive. It has been to a few events and caused decent damage, as well as a fire or two. This one in Melbourne led to a brief evacuation of the venue. What's even better than an Antweight fire is a Beetle fire. Scale caused one last year that similarly led to a hold on proceedings while things were dealt with. Most robots in this sport consist of two drivetrain actuators and a single weapon actuator, but I reckon things get far more interesting once you add one more mechanism somewhere in the mix. So why not combine all these things and make a hammer saw Beetleweight that's fun to drive, a challenge to develop, and might cause a fire if we get lucky. But rarely do things go to plan quite like that. This video will cover the development of Subdivide B, my Beetleweight hammer saw, as well as my attendance at RH7 in Adelaide. I brought a number of robots to this event, all of which will be covered in this video. So Subdivide B is obviously a scaled up version of Subdivide A, but with a completely unique construction. The 150 gram Antweight uses simple off-the-shelf N20 motors for the drivetrain, which are bolt on and go. The 1.36 kg Beetleweight will require a fully custom brushless solution to get the performance I want. Similarly, the robot's weapon is just a bar epoxied to a drone motor, whereas physics is enabled for heavier robots, so the new one needs a properly engineered assembly. Finally, a good arm mechanism is no small feat on big robots, in that it must have the torque and power to actuate while not self-destructing on impact. While maintaining all that, we need to keep what's good about the Antweight. It had a big, hard-hitting weapon that swung fast. The air-gapped armor protected the drivetrain excellently, meaning it has never taken damage to a wheel or drive motor in 6 events. Finally, the weapon is mounted to a rigid arm that ensures the weapon's destructive force is maximized as much as possible. There are also a few new things being trialled here. Foremost are AM32 ESCs to replace my usual BLHeli-S. Next is a more print-heavy design compared to the last Beetle, which was 95% machined. Most significant is a new transmitter and sensor arrangement. Rather than a more common dual-stick transmitter, this robot will be controlled by a pistol radio. This isn't good at controlling the arm though, as both hands are preoccupied with the drivetrain. Therefore, a gyroscope module will control the actuator. There will be more on this later. The general structure concept I had looks something like this. 2 aluminium rails support the weapon and give it strength. The drivetrain mounts, 2 separate aluminium blocks, and long shoulder bolts with top plates couple everything together. Ideally, the chassis has strength and rigidity from the metal skeleton, while the tough print distributes impacts and easily shapes up to complex geometries. Some ideas were scrapped early on, such as ring gears on the drivetrain or a dual motor belt drive for the weapon. What followed was the usual slow march of iterative concept development, building off of the starter block CAD. I should point out that up till this point, every one of my robots has been designed with direct modeling, rather than anything parametric. It lends itself better to this method of forming a robot from a concept, like one is molding clay. Some future robots will need to be done parametrically though. Eventually, we land on more or less the final design. From front to back, we start with the attachments. Subdivide B fields 2 setups. The first are those CNC machined, hardened and sharpened, borderline sacrilegious steel forks. These will be exclusively reserved for opponents that lay down the ground game gauntlet and should get under basically anything at the cost of getting hung up on slight deviations of the local space-time continuum. The more common configuration will be a large 3D printed TPU wedge. I fully expect this part to be trashed by the end of the event, but ideally it is so compliant it's incapable of transmitting enough force to the rest of the robot to cause damage. Next are the main structural plates. Fairly simple, but will be my first attempt at machining both internal and external fillets. Both this outer edge and the pockets will be finished with a radius and ball mill respectively, for aesthetics. Then comes the chassis, another large 3D printed piece that while floppy should be incredibly tough. Centrally located we have the arm mechanism. It's very hard to determine the starting torque of sensorless drone motors without a dyno, so this one will be done by intuition. A 7-to-1 overall reduction from the motor means it will do 3.5 turns to throw the arm. For maximum durability, the first stage is steel gears, then driving 3D printed gears that might absorb some shock. I really hope this design works, as fitting a higher reduction after assembly will be very difficult. What I do have going for me though is the massive motors featured on both the arm and drivetrain. Motors of this size comfortably move 5kg hobby weights around the arena, and they've served my purpose in previous Beetleweight experiments quite well. They're also very cheap for the quality. Speaking of said drivetrains, these gearboxes are designed to be as dead simple as possible, as drive failure on this archetype of robot is fatal. One aluminium block has mounting holes for the motor and a counterboard thread to receive a shoulder bolt. I couldn't fit a nut to receive the bolt due to the proximity to the motor, and the simple thread is a terrible locator for the fairly sensitive center distance of the gears. So a counterbore receives the precision ground bolt shank, and the thread keeps it from just falling out. Got to use a lot of Loctite though to avoid it backing out when the wheel is turning. Finally is the weapon hub motor. A minuscule 2004 motor is cut up to sit inside a machined hardox bar. Some aluminium components locate bearings, the shaft and mounting bolts. All weapon force travels into the tooth, through these bearings, and straight into the carbon fiber weapon arms. The shaft is exclusively there to keep the motor from splitting apart, and also to locate the motor stator. Brass flywheels were added as weight was available, bringing the weapon mass to 150 grams. Initially, a 3,500 kV motor was fitted, but this was later almost halved to 1,800 kV due to the event's tip speed limits. One last detail, most of my designs have been based around chamfers and hard corners, whereas this machine is meant to be more fillet and curve themed. From a side view, there's a clear line from the hammer saw down to the chassis that then flicks upward to give the machine some coherence. It doesn't do much competitively, but it does look pretty cool. With all the parts machined, assembly went smoothly. I originally intended to epoxy the weapon motor magnets into the Hardox bar, but the fit was so tight it was merely pressed into place. The brass elements weren't machined as flat as they could be, so needed some clocking to the most parallel planar orientation for smooth running. For next revision, I would figure out a design that doesn't require complete disassembly to access everything, such as larger bearings to allow the motor to slide out unimpeded. As usual, the drive and arm motors were disassembled to replace the shafts with longer ones, enabling a pinion to be pressed onto the end. That whole process can be done with a hammer and punch once the set screws are loosened. Pinions can be purchased that are a simple press fit onto 1/8" shafts. The printed chassis came out well from the X1C, and not surprising is super flexible. ESCs need to be flashed for the proper characteristics. A cheap adapter from AliExpress allows you to connect the ESC to a PC and set the settings however you want. These 35 amp AM32 ESCs are around $28 a piece, or $19. I flashed them with these settings, disabling sinusoidal start and maximizing the timing advance. The drive received 100% startup power, while the arm gets 150 because it probably needs it. Unnecessary startup power can make the drivetrain twitchy. As a general rule, the only connectors I put in robots are the ones for battery power, as any others just use space and are failure points. Here though, the weapon motor gets a 3-pin JST to allow the separation of the arm from the rest of the robot if needed, as the space wasn't being used for anything anyhow. Heatsinks and heat shrink are removed from each ESC, and they're wrapped and capped on tape to reduce their thickness. Generally, thinner than stock wires are also used. At this point, I have not printed the wedge or machined the forks. Those two parts aren't required for testing, and would only be a waste if things go to plan. PLA stand-in forks are used in the meantime. Same for wheels. PLA stand-ins with O-ring tires works just fine for testing. The robot was assembled for its first ever motion test. Overall, a good result with each mechanism working as expected. The drivetrain is fast, but I have exclusively driven Omni-Drive Beetles up until this point, so practice was necessary. As for the spinner, it sounds menacing, but the spin-up time is around 7 seconds. It was tachometered to be just under the event's tip speed limit of 80 meters per second, so slow for a Beetle weapon, but also it's what I got to work with. Thankfully, the arm mechanism worked a treat. It's so powerful that it can do a standing front flip. At this point, finishing touches were made. The wedge was printed successfully, and a set of forks too were machined from Hardox. Polyurethane tires are cast and significantly improve the driving over simple O-rings. By now the robot is complete enough for competition, and time was dedicated to a few other machines. Scale is mostly unchanged from its previous Robot Havoc appearance almost a year ago, besides the thicker weapon axle. Due to quite low tip speed restrictions, the weapon motor had to be replaced from a 2500 kV to a 1400 kV one. This is as simple as disassembling, drilling, cutting up, and pressing the motor in place. With that, it's ready to go. I didn't bring any forks or spares for this robot, as it was more or less just thrown in because it still worked. This one was a project that didn't quite make it, a Beetle multibrain with a strain gauge for the accelerometer. Electronics problems meant it couldn't be finished in the time, but work is ongoing for the future. DES, or Dynamic Event Simulation, was an Antweight robot meant for another video that never went ahead. All it needed to compete was a weapon bar, so this 40 gram, 5.5mm thick Harlock piece was cut and installed. The weapon motor on this robot is actually bigger than the one in Subdivide B's hub motor. Derive and Subdivide A are two ants that were sort of just ready to go from previous events, so they were thrown in. Finally is Revolve, another Antweight mostly ready to compete. It's still sporting the titanium ring pieces provided by PCBWay, as they survived the previous events without much trouble, the first ring design of mine to achieve that. I found the thick Hardock's teeth struggled to damage TPU armoured robots, so I machined some thinner ones from old saw blades. It took a while to get the speeds right. No, it really shouldn't look like this. Eventually I ended up with a pair of nice new teeth. With that, the fleet is ready and things were set to head off to Adelaide. Each event in Australia is run a little differently. RH7 was going to be run as a combined Swiss bracketed schedule. Robots are placed into randomly assigned groups and fight a couple times within said group to be assigned a ranking based on their own score and the scores of the opponents they defeated or lost to. The top 2 robots from each group then enter a standard finalist bracket. Anyhow, I've got a lot of robots to show footage of here. Antweight matches were recorded as usual, but the Beetleweight fights were done in slow motion on my phone under the impression that I could use the arena camera footage to supplement it. Unfortunately, what that camera picked up wasn't great, and the audio being quite scuffed. I've done my best to piece things together coherently. Once set up at the event and having passed all safety checks, I put Subdivide B into the arena to fight an RC car for fun. In his first fight, the spinner caught and ate the car's tyre, but more worryingly is what happened to the match after. A dry swing of the hammer caused one of the arms to snap cleanly in half. This was a pretty massive problem. I didn't make any spares of the arms, but more concerningly was that the 2 arms were made more or less identical. If that one failed so easily, then the other one probably didn't stand a chance. I lathered both arms in epoxy to see if I could at least get one good swing in anger. Ready or not, Saturday began, as did the Antweight matches. After all that, here are the competition standings of each Antweight robot. Derive sat at 3 wins and 1 tie, the latter of which it really should have lost, but it is what it is. Revolve 4 had 2 losses and 1 win. DES had 2 wins and 1 loss. Finally, Subdivide A was sitting pretty at 3 wins. From these machines, Derive A and Subdivide A would progress to the finals. The Adelaide Ant Arena is small with a quick opening pit, therefore it's no surprise that the control-based 4-wheel drive robots did well, whereas the chaotic robots struggled. Despite that, Revolve 4 was fully functioning. The only damage was the motor stator falling off due to inadequate supergluing. Now for Subdivide B's first fight. Due to last-minute bracket changes, it was drawn against a huge clone, which might be one of the worst things it could have faced. I screwed 2 bolts into the wedge to maybe have a chance of pinning their robot. I figured that I might be able to land a box rush, but I would quickly regret that decision. So this wasn't quite the opening fight I had hoped for. Business Time justly punished me for my hubris and smacked a drive motor very early on. The epoxy on the arm broke too, so from there it was down to taking punishment until it eventually stopped. I'm not sure why the other drive side wasn't working, perhaps it was held up on some debris, but nonetheless a deserving win for my opponent. At this point I spent 30 minutes or so moping around before getting my act together to repair the robot. Despite the wedge being split in half, the frame was almost untouched, with the arm still working. The drive motor and PLA top plates obviously failed, as well as nicks to the drive gear, but I had spares for all of those. Coupled to this, a local builder, named Doc Steve, had 3D printed me some nylon arm pieces to replace the carbon fibre ones. Once the drive had been fixed, my next match was up.
Okay, guys, everyone. That's helping these drums get around. Here we go again.
Aside from the rumble later, that's it for Subdivide B this time round. The hub motor weapon got a little crooked in the first fight. The added resistance limiting it to maybe half speed, but it still did some damage. First is the picture-perfect link snipe done positioned perfectly for the camera. When it fought the Melty Brain, it cut through 6mm of HDPE and nicked the microcontroller, stopping it dead in its tracks. So even with the setbacks, it managed to KO 2 robots on its own accord. I was super happy with the transmitter and gyro setup that proved very intuitive. For a moment though, we'll pause on that robot and take a look at one with 3/4 of the drivetrain.
semifinals. We'll have 2 more matches for you in the special.
3, 2, 1, fight.
Quite the ride with this machine. During the semi-finals, the top plate got hit so hard, the battery was shifted 20mm into space that wasn't available, forcing the electronics to squeeze out of the top plate. Said battery was smashed up but still worked, so I pressed it back into shape and put it back in for the finals. The final fight was probably the smallest robot in the event against the largest robot. Weapon engagements were even up until the top plate was sniped and ripped off, exposing the battery. The right drive gearbox got smashed too, so fair game there. At this point, the entire robot was so clapped out, I was surprised it worked as well as it did. Look at how much play there is in this drive gearbox. The weapon bar too is so dull it only catches sharp metal edges anymore. Nonetheless, we've still got the Antweight finals and rumbles to go. Firstly, Subdivide A is matched up against the Antweight version of Business Time.
Match in 3, 2, 1, fight!
You can just die now, okay?
James doesn't know the concept of dying.
Oh! 2, 1, fight!
That's why we played it, and I think
Stop.
Right about it being ripped.
Well done.
A good result with Subdivide A taking first place. As both Derive and Subdivide were on the same side of the bracket, they ended up matched against each other in the semi-finals. Therefore, I had to pick which one got to progress. As for the hammer saw on Huge Clone rematch, I had time to prepare for this one, so superglued some cable ties to the wedge with the few grams I had to spare. In real time, they seem to have not been effective, but if things are slowed down, it's obviously absolutely kept Business Time's weapon away. At this point, I could just push them around into the pit, but that makes for pretty poor form. The hammer did smash their chassis open and expose the weapon ESC, but didn't break it. A semi-final fight saw the hammer saw snipe blade tip's power switch between the chassis and wheel, which finalised the fight. Both finalists, of course, were 4-wheel drive forked robots. A bit tentative to begin, but after getting their drive belt pulled off, it was into the pit for them. I put Revolve 4 in for the Ant Rumble to give it the ultimate test of durability. It smacked a few robots around, but Avert clipped the ring up and off the rollers. Unfortunately, the same failure mode as last year. It got hit a few more times until the closing moments of the fight, where it was one of the last robots still working. Fixing the ring was as simple as popping it back onto the bearings. It seems it wasn't ring expansion but chassis flex that led to the failure. Thanks again to Beetleweight for supplying the titanium rings. They survived far better than any of my previous iterations. One last fight in the event, a Beetleweight Rumble. I put Subdivide B in, as it still had a thing or two to prove. good showing with some real damage done by the hammer saw. The arm broke again early on, but with it being the last match of the event, the only thing to do was to send it anyway. Because the tensioner axle had been snapped off in its first fateful fight, there was nothing holding the weapon from coming out except for the slight friction from an undersized 3D printed hole that did eventually come out. To round off the event, Scale did one better than its predecessor, upgrading from 3rd place to 2nd. Subdivide A got 1st, and I won the community voted Best Driver award. So now a roll call. DES was a fun big vert, but very difficult to drive. For the moment it's relegated until I can figure out what I want to do with it. Drive A worked as expected. Not sure why such a small vertical spinner can do so much damage, but I'm also not complaining. It's ready to compete again next time. Subdivide A did its thing, with no arm failures this time. Sydney builders can look forward to seeing it again in October. Revolve 4, despite not winning many fights, was the most reliable it's ever been. While considering its previous events, I'd also say it's the most destructive ant of mine to date. It needs a frame revision though, with the 15 grams it is underweight. Ring spinners will be forever on this roster. Scale surprised me by actually being kinda good. I hadn't really touched this robot in a year, and it was pretty much done with the concept, but this event has revitalised it for me. The Omni drive can't keep up anymore, so a 3-wheel swerve drive version is in the works. You can see the concept module here. We'll likely move away from billet HDPE to a printed chassis too, based on the data we got out of the other Beetle. The next version is in development. Subdivide B drove excellently once I had my head in the game. The air-gapped wedge tanked everything thrown at it, and the arm never stopped working. I believe the freak failure of that one carbon fibre arm was probably down to the cheap Chinese stuff I bought, but this needs further investigation. The pistol radio and gyro setup felt very intuitive. I drove the Antweight with the same control setup to get extra drive practice. From that data, I reckon the gyro is really only suited to hammer-type mechanisms. While the resolution is there, it's very hard to control a lifter with it. There's a link in the description if you want to check it out for yourself. We'll fix this robot up and enter it in the next available Beetleweight tournament. And that's all I've got from this event. Apart from a few Antweight fights in the next showing, will likely be some feather action next year, depending on when they're scheduled. I'm working on a Sportsman flywheel flipper, so stick around to hear about that. Until next time.